Graham, we're good to go.
Okay, so good evening, everybody, and thank you for joining us at this webinar. My name's Graham Hastings. I'm actually in the UK right now, and I've been asked to introduce and also to possibly answer some questions later on, using my extensive knowledge of coding and robotics going way back to the 1980s. So I've been in it a long time. The people with me also experts in this field, and I'd just like to introduce them to you. So we've got Keke. Keke, would you like to say hello?
She's not here right now. She'll be here in 5 minutes, she said.
Okay, all right, fine. Also, Karen and David. I suppose I should say a little bit about them. So Karen is an experienced teacher in grades 3 to 11. She works with educational organizations on educational change and digital integration, coding and robotics, AI and VR. She also does leadership support and engagement. The focus for this evening will be on teaching ECD learners and the basics to coding and robotics by integrating computational thinking skills in early learning, initial number and reading skills, and unplugged coding in grade R. David is making software work, Capitec, Afro Labs, Coda, Level Up. That's what he's involved in now. And his focus for the evening will be where to go from, and he will pick up from what Keke and Karen say. So where to go from in coding and robotics beyond the curriculum. So coding clubs and innovative projects, and also on developing creative learning. So those are your speakers for this evening, and I would like to introduce Karen, who's going to speak now.
So hi everyone. You need to go outside quickly. So I'm going to be talking about looking at ECD in terms of how we actually engage with little children in the space. I'm assuming you can see my screen. So we need to be thinking about teaching them coding and robotics even from very, very little. So And so we're looking at a range of different things in terms of coding and robotics. So when we look at the curriculum, you'll see that the house over here is the coding and robotics curriculum that's been developed. And how do we actually integrate some of these concepts into what teachers learn? So we've got the South African National Curriculum Framework, which the ECD and foundation phase teachers work within their spaces. So let's think about this. There are 3 core themes and 12 principles within the space. So being a competent person, looking at their learning development as being important, and having strong connections with adults in terms of the world and how they grow. And then the 6 learning areas within the space are identity and belonging, communication, exploring maths, knowledge of the world, creativity, and well-being are within the whole space in terms of health, safety, and physical development. So let's look at a few really practical examples. For example, if we look at the early learning development area 3, communication, how do we develop the meaning for reading? How do we actually grow reading within the space? So what about things like getting your children to actually talk and explore and play with different shapes, getting them to talk about colors, listening to sounds, and comparing and identifying different things. Or if we look at it from a reading point of view, if we talk about getting our children to actually discuss, how often do you get the little children to talk about and discuss different things, to listen and to mimic, encouraging them to experience the spaces around them? And when we're doing all of these things, if we relate it to computational thinking, we're getting them to pull out what's meaningful at that particular time. So looking at abstraction, they're identifying different pieces that are appropriate and breaking things down so that things make sense. So looking at decomposition, they're perhaps following a set of instructions that the teacher has given. So being introduced to algorithm design. So all of those kinds of things can be added. What about getting your children to listen? Little children today, the teacher might have a phone and they could walk around and record different sounds within the school or in the outside of the school and then play games later recording them. Or as the teacher could record sounds and get the students to recognize what those are, maybe having pictures or cards that could recognize it from that point of view. Or what about developing meaningful reading where they are exposed to their identity and their belonging and trying to recognize the letters that their names begin with? So, for example, starting with little children in identifying, finding letters with holes and finding letters with no holes could be a good start. And then getting them to pull out the letters which are their letters that their names begin with. Or what about getting the children to experience play and as an introduction to writing? So, for example, drumming and experiencing with sound and seeing how does that then relate to allowing them to follow instructions and getting them to experience play and at the same time developing their fine motor skills within that space. Or what about getting them to recognize the letters by playing with either Play-Doh or making actual cookies and cutting out the shapes with cookie cutters? Or what about getting them to reinforce math skills and at the same time developing their own well-being within the physical spaces? We have all sorts of objects all the time. What about getting the children to talk about the colors and matching the colors to the shapes? And so then having to decompose information or having to recognize and pull out pieces of information. And there we're building on or reinforcing the abstraction skill. What about giving them specific activities such as shape cards, where the children then have to recognize the different types of shapes? What are rectangles? What are triangles? Or perhaps creating their own shapes and building pictures. For example, the ones you can see over here where the children who were little would try, these were 3-year-olds who were trying to build a house with the teachers in an ECD classroom and getting them to recognize the shapes. So again, how are we getting children just to be involved in the activities and reinforcing the skills that they are doing? What about getting huge, big shapes that the children could walk around and can actually perhaps get cars to play on? So here we're getting them to reinforce shapes and geometry and introduction of geometry within math. And at the same time, they're now having to recognize the patterns. If you interlink the shapes, they would have to then find the shape which you've told them to go and follow on. The children could be giving other children instructions of what they're going to do. And at the same time, they would be having to solve the problems of working within that space. Or what about getting the children to play with numbers and getting them to recognize different numbers? Or what about building shapes and things like insects that are using different numbers? So developing creativity within the children, within a range of ways. It doesn't have to cost money. If you look at the range of examples I've shown you, most of the things are reusable activities. But at the same time, you're developing the children's thinking, you're exposing them to these different concepts. They don't need to know the words, but you as the teacher are recognizing how these concepts and these terms in the long term are developing their computational thinking, which leads into the coding and robotics that they would do later. So we don't expect the children to use these words. But as a teacher, if you recognize them and know they're doing them, you know in a way that you are building these skills within the children that you're doing, and it's interwoven into what you're doing in your classroom. What about the outside activities? The same applies. Again, you're getting your children to solve problems, you're getting them to follow instructions, and so again, you're developing computational thinking skills. What if we go now into activities which are real robotics? So looking at unplugged robots like B-bots or the robot mice, where the children are now beginning to use the little arrow sensors. If we look at the top, both of these have the same kind of top, and the children have to program them. Here you're introducing them to all the different concepts of computational thinking by following the instructions and having to learn how the different arrows work and how they would use those. Or what about getting the children to be creative within their spaces and becoming little robots, whether they're building themselves, whether they're models, or whether they're climbing into boxes and being used, and seeing how those can be used to develop the children within that space and seeing how that would work. Again, developing all the different computational thinking skills. They could then follow the instructions that the teacher's given when they dressed up as these little robots. Or what about using completely unplugged type activities where the children can actually solve the problems, create the arrow code? So if we look at the top over here, here's a very simple algorithm design that the children then have to follow and make the patterns on the board. So introduce them to the basic concepts of coding. And then what about introducing them to Scratch Junior? As you know, the curriculum uses Scratch from from a foundation phase all the way up. And so Scratch Junior is a wonderful space to start for grade R, grade 1, and even grade 2, where the children can be coding within the space, but it works on an app and they drag and drop the symbols within the space. So think about how you can be getting the children to be using all of these, whether it's physical robots, whether it's being creative with available resources, or whether it's using unplugged coding type devices. Get the children to really think and explore. Get them to really develop their foundational logic. Get them to solve problems and become really involved in the activities around them. Thanks, everyone.
Okay, so thank you, Karen. It's very interesting, and I hope that people gained a lot from that. What we will do, I think, is save any questions that people have until the end, because we'd like to get through the talks first, just in case we get short of time. So I'm now going to introduce Keke. Keke, are you with us?
Yes. Hello, Keke.
Okay, I'll hand over to you then.
Thank you very much, Karen, and thank you very much, Graham. I'm quite happy, and hello everybody that has joined us. So I will be looking at the topic of today, which is demystifying the coding and robotics curriculum. I'm hoping that you already started at your school rolling out coding and robotics, and if you haven't started, I'm just hoping that probably you are going to start very soon. Please allow me to share my screen as we unpack together what this means. So I'm going to take you through the overview of the CAPS coding and robotics curriculum, which is used in South Africa. We all know that the national curriculum statement, which CAPS is part of it, it serves South Africa's broader NTS, which emphasizes democratic values, social justice, and equity in education. So we need to understand what exactly are we looking at when we're talking about the coding and robotics curriculum. Let's have a look at the policy framework. It was designed to transform education to meet digital economic needs. It was designed to ensure that there's equitable access to 21st century skills. It is designed to align with constitutional principles of inclusivity and empowerment. So there are two main important things that one needs to look at, which is quite important. And that is, one, you need to understand the national curriculum statement. As an educator, you need to know what is expected of you. You need to also understand the curriculum assessment policy statement from a South African context. So let's dive deep into the curriculum that has been introduced to us by the Department of Basic Education. It is mandatory that at least learners from grade R to 3, which is the foundation phase, and my colleague Karen has already unpacked what is required to be an effective educator. The curriculum was designed to ensure that there's progression of skills, integration of coding and robotics. So what exactly is this coding and robotics, and why do we need to teach it? So naturally, it just fits within the STEM framework, which is science, technology, engineering, arts, and mathematics, because it blends technical problem solving skills and with creativity and design thinking. So we need to understand that we need to explore science. Learners, if you use science, the element of science, learners explore scientific principles like energy, motions, and system when building and programming robots. The technology aspect of it is just a matter of coding introduced to learners, for digital tools introduced, algorithms, and the one that I like the most is the computational thinking. Engineering as well, it's introduced in this case where learners can do projects that require design, prototyping, and testing, and mirroring engineering processes. So it is quite critical that we include the element of arts. Creativity is essential in designing robots, storytelling through coding projects, and maybe using design thinking to solve problems in innovative ways. Mathematical component of it, it's basically coding and robotics rely on logics, sequencing, geometry, measurements to program movements to solve these challenges. So we need to be able to help children to develop resilience and adaptability. So without wasting any further time, when I go into most of the schools, it has always been, let us unpack what the Department of Education requires from us. The specific strengths that the Department of Education requires from you. The first one is coding, which it's really a process of creating logical sets of instructions. Robotics, which I've explained that it deals with more of design operation. Digital concepts, which is a range of digital literacy skills. And you need to be aware. I always say to educators that if you ask any learner about who is the latest, what is the latest Amapiano song or any song or any genre that they like, they're able to say it. But if you ask educators about really what is really happening in the coding and robotics space and what is happening in the Western Cape government, who is best at maybe selling robotics equipment at the moment, or probably are there any new things that have been released? Quite frankly, I don't get answers. So now let's just unpack what this means. You're building a house here, and when you're building a house, normally you start from the foundation. So you need to understand that there's certain steps that you need to take in order for you to understand coding and robotics. You first have to develop the computational thinking, and there's 5 sets of things that you need to know. So that requires you to understand the decomposition, the abstraction, the debugging, the algorithm, the pattern recognition, and you need to know that because that develops a sense of foundation for you to be competent in these strengths. Once you've done that, you will develop automatically the logical thinking, which will give you the logical approach on how to approach problems. And it is evident that once you know how to approach problems, it is quite evident that you would also be able to have the design thinking in order for you to help solve problems. So once you've acquired these steps, then you have to enter into your house and you enter through the door with this digital concept. You have to be aware of what is happening around you. You have to be a responsible digital citizen. Then you'll be inspired to come inside. And obviously, in your house, you have different rooms. In this case, you've got coding and you've got robotics. So I've already spoken about the steps of computational thinking, which forms a very strong foundation for coding. So it is important that you know all of these. And as for robotics, you will be inspired, and obviously there will be a lot of ideation because you need to create new things, and it just makes it easier to implement. Automatically, you will house your roof with a cross-curricular integration. which will then mean you'll be self-efficient, you'll be able to motivate your learners, you'll collaborate with others with ease, and not only that, you'll be creative. So let's look deeply into these trends and maybe into the competency before I touch on the pedagogy. Just to unpack it and make it a lot more easier for you to understand, the strengths has competences. Coding has C1 to C7, meaning educator. It is your responsibility to understand what those strengths are and why you need to be competent in those strengths. As well as robotics has got R1 to R7. Digital concepts has D1 to D7. So to make a practical example, you have been hired to become a chef in a restaurant. So you would need to be able to cook 3-course meal. So obviously you will have our starters, which is coding, and you have, the main meal, which is robotics, and, we'll just have the dessert, which is digital concepts. So for you to be able to give us the menu that we love, you would need to understand how to cook all the starters or how to prepare a starter menu. So that is why you need to be able to be competent in all the strengths that the Department of Education has outlined for us. It is your responsibility to understand C1 to C7, R1 to R7, D1 to D7. I cannot emphasize any further on this. Let's have a look at the pedagogy that we're using when we are using when we're talking about coding and robotics. The CAPS coding and robotics pedagogy is designed to be inclusive, progressive, and practical. The sad reality is we have challenges where there's lack of access. And I'm not here today to explain the challenges because it has been simplified to you that you can start even with little resources, with no resources, because the tools are available for you to use. Karen has unpacked the ones that you can use for foundation phase. The pedagogy that the Department of Education uses, it's pair programming, meaning the two learners work together at one device or computer or using one robot, and one can write the code and the other one can review and have guidelines. We also use project-based approach. What that means is learners engage in extended projects that solve real-world problems, often integrating multiple STEM disciplines. Then we've got inquiry-based learning. I'm not sure if other educators use this, but this is where learners explore concepts through questioning, experimentation, and discovery rather than the direct instruction. So now, how do we then approach the curriculum? Because if you look at the CAPS coding and robotics curriculum, you've got a 138 page or 130 something page, and you're looking at it and you're like, okay, I need lesson plans, but the lesson plans are already there. They're designed for you. So really the question now is probably it means maybe you do not know how to approach it because there's so much information in there. So the curriculum approach is quite important. So the approach to the coding and robotics curriculum is designed to be progressive, inclusive, and aligned with the South Africa's broader education goals of preparing learners for the fourth industrial revolution. Accessibility, very important that all learners have at least access to be given opportunity to learn coding and robotics. Cross-curricular, integrating other subjects into coding and robotics. Educators, you do not need to neglect everything that you know or that you teach in your subjects. All you need to know is to understand what is required of you so that you can use the cross-curricular approach, which then will also address some of the issues that Karen mentioned earlier on in terms of numeracy, literacy, as well as language. It has to be progressive because if it's not progressive, otherwise we'll get bored. That is why coding and robotics is so fun, because we don't do the same things every day and we get to discover new skills. And guess what? Imagine starting up coding and robotics in grade 8. In grade 8 or in those senior phase, a learner is now required to at least program in using text-based approach. So if the learner did not get the foundation and the principles of actually being able to learn coding and robotics at an early age, the disadvantages of that is that they would have lost the fundamentals. It wouldn't be easier. They might say it's hard because maybe they're now doing coding and robotics through text and now you're teaching them Python and all these other things. However, the South African coding and robotics curriculum, it's easy. Looking at the intermediate phase, well, it is only designed, or maybe I could say uses mostly Scratch and microbits. Well, if you didn't know, 80% of the curriculum is actually based on Scratch and the microbits, which is an easy and a wonderful tools to use. So let's explore how to read the policy document with understanding. If you could allow me to quickly open up my FP document with you for CAPS coding and robotics, and maybe let's just have a look. It could be anyone actually. It doesn't have to be the senior face. I know Karen covered the foundation phase, but what I wanted us to have a look at is basically to say the lesson plans are already there and they're designed. If you look at the content of the coding and robotics document, it tells you per week on what you need to cover. So it is quite important that you as an educator, you go through this book or this particular curriculum and you understand on the 136 page on what is required of you, because every grade per term per week, it gives you exactly what needs to be covered. And I apologize that my document is upside down, but definitely when you get this document, it will also be like that. It is your responsibility to ensure that you are able to unpack it. Without wasting any further time, due to time, I would like us to have to explore more, but I can realize that I only have 3 minutes, and I would have loved us to look into Scratch as well as the Make code. However, Scratch is a very wonderful tool that you can actually use in order to teach your learners to learn programming. It's easy because it uses block-based programming. On your left-hand side, you've got your blocks that you use, and you need to understand all what these color blocks simulates, from motion to looks to sound. And you've got your Canva here where your learners could program. All your blocking codes will come here. However, when you've got your sprite, you can control your sprite using this dashboard here, because it allows you, the X represents the horizontal area, the Y actually represents the vertical area. You could insert backgrounds, you could do a lot of things. I would have loved to show you, but we don't have time. Then comes my favorite, the Make code. Make code, which is a product of the Microsoft, is an IDE that allows us to actually teach coding and robotics. Has a lot of robotics concepts as well as electronics. Learners can use project-based learning approach where, the educator uses project-based learning approach to design certain projects that allows us to be able to program. And you do not also need to have a microbit to do this, or you have a virtual simulator that will allow you to actually code and you'll be able to see exactly what you're doing. For an example, I'm just going to do a basic one, which I really like to switch on the lights and switch them off. Let's just call it that. So if I do that, I will have probably a solid X simulated. Okay, so should I wish that it must flash, in this case, switch on and off. All that I would need to do is to go back to my basic. We can pull through the show LEDs blocked, and look, it just flashes. Did I have to have any resources for me to learn coding and robotics? No. You just need to know and find the right tools, educators, so that you can be able to teach your learners. Activities and tools, that's what we've covered. And without wasting any further time, let's empower minds and let's bridge futures together. I'm from United Siyafunda. Thank you.
Okay, thank you very much. This is very interesting for me because I've been working with these tools for a long, long time, many, many years. I remember when Scratch first appeared in schools a long time ago, developed in the United States, now used all over the world, and forms the basis of many, many schools' curriculum, or many, many national curricula for teaching coding and robotics. And then the problem was, how do we engage learners by making the subject more dynamic, and so bringing in things like robotics and also sensing and control. So sensing and control, robotics, there's a problem here. We need hardware. And so in the UK, the microbit was developed to allow schools, primary schools upwards, to get into this physical computing. And so that now is alongside Scratch, one of the most important tools for teaching coding, robotics, and physical computing. But the brilliant thing is that they're not just a coding environment. They are a course in how to use them in the curriculum. And so if you go into them and explore them a bit, you'll find tutorials to use with your students, your pupils and learners, but also tutorials for you as an educator to learn how to get the most out of these tools. I think we'll put links to them in the chat. Anyway, I must not take up any more time because David he's dying to give his talk, and it's, I think a lot of it is to do with how you develop creative learning. Is that right, David?
Yeah, precisely, Graham. And I think you've pretty much lined up why I care about this area and what I want to talk about. So I'm going to see if I can get this tab to share.
Okay, I'll over to you then.
Cool. Let me have a look. If I share screen, is it going to want to do my whole screen? Oh, great. I can do that. Wonderful. Okay. So I came across this phrase, which has really come to explain to me what it is I really want to do with learners and what really makes it come alive. And this is this idea of creative learning. So creative learning is this idea that we want to help young people find this creativity inside themselves. And the way we do that is actually by making things. And we learn to make things by making things. So when we learn creative learning as educators, we're learning how to start this cycle of creative learning. The 4 Ps that underpin creative learning we've heard about today. So you've got projects. So we've talked about projects in Scratch and Microbit, and people have talked about all sorts of different unplugged projects and things you can do. Something you can do where you make something that naturally needs us to be passionate about them. We need to care about it. And then we want to show somebody else. So we need peers in the environment. And then lastly, we want to be able to do it in a way that we feel safe. So we want to do it in a playful way where you can try things out, you can experiment, and hopefully discover something new. So if we think about these 4 attributes putting together, I would invite folks in the comments to share what you think of when you think about a creative learning environment or where you might do creative learning. While we talk about that, what I'm going to share with you today is a bunch of website content, and then I'll share the links afterwards. So there's no need to get the slides because they'll all come from the website. So these 4 Ps of creative learning come from Learning Creative Learning, which is a free online course and a community from MIT. There'll be another course opening in April this year. They haven't done one for a few years. So I would encourage, if this is interesting to you, if you want to figure out how to actually create creative learning in your peers, this is a place where you can watch, read, make, and share and discuss with people like you from around the world. It's offered in, I think, 6 languages now this year. We're going to learn to make with specific technologies, 6 modules. I highly recommend doing the course because that really helped me understand what we mean by creative learning. And this course comes from the lab that actually created Scratch. So Scratch is probably the best constructed creative learning environment I've engaged with. So when we think about creating a creative learning environment, I'd like you to think about your classroom. If you think about a good classroom, it's got a low floor. It doesn't have a giant step at the entrance so the students can't get in. We want to lower the floor so it's easy to get into the classroom. But then we don't want to feel cramped. We need a high ceiling to be able to explore what's going on there. And then we kind of need to be able to try different things because not everybody wants to do the same thing. So we need wide walls. So if you've got that picture of your classroom in your mind, it needs a low floor, that ramp at the door. There's a high ceiling and wide walls. So if we imagine designing an environment that has those attributes, Scratch is a great example of that. Now, I'm going to help Keke out because she said she didn't have time to show off this tooling, And I'm going to jump into what creative learning looks like in Scratch. And I've clicked one button. There's this little video.
With
which
Scratch,
is
you can make
to
your
have
own
a look
story.
through with the learners, and they
Let's
get an
start
idea
by
of,
grabbing
this is what I might make. Oh, a dance
to
party, a
run,
moving
easily
cat.
reorient,
That's
and
interesting.
coding.
But now we're here. And it's time for creative learning. So I'm just going to make this window a little bigger so that I can see it all. I made it smaller to see the controls. So now I'm sitting here and I'm worried and I'm scared. And Keke showed me that there's blocks, but what am I actually going to do? And this is where we need to think about how do we start to play. So we've got a cat, and if we click on the cat, you can move it around, which is great. Well, that's quite fun. And then, I mean, most young people I know like stickers. And we've got a whole book of stickers in here that we get to play with. So our cat, you can say, who should our cat be playing with? Oh, look, that's a silly duck. And now at this point, you can have a good old laugh and have fun, but there's a cat and there's a duck. And then we say, well, where should they be? Right? This is an interesting question, because now we can actually be telling a story. I often get drawn to this castle. I love this castle. Or they could be in the city. They're probably not floating in space, but some people might choose that. But maybe this hill looks like our story for today. So there's a duck on a hill, and he's shouting at the cat, maybe because the cat was stealing his eggs. Now, depending on where your learners are at, what you've just done there is quite a phenomenally fun thing to do. You can start to tell stories, make pictures, and especially if you have a school where resourcing is a challenge, but you do have access to some devices, you can use those devices to have that endless supply of color backgrounds, color stickers. And, you know, those Melissa and Doug sticker books at the P&A cost a fortune. And we've just got tons of these stickers. We could play with them and keep going. And that's a great starting point for creative learning, to do that, make characters and show each other your story. And then we might say, well, what do I want them to do? And we might say, well, I want my cat to say hello. I clicked the block and he said hello. How cool. Can I make my duck say hello? I clicked the block. And so when we're talking about demystifying coding, well, I just gave them instructions, but I didn't code them. And what do I mean by coding? I mean giving you instructions that are part of your program. So we look, here's our duck. Our duck needs a program. So our duck needs to say hello. And we say our program says when we click the green flag, then our duck must say hello. So now, or maybe he can say quack, because ducks don't say hello, do they? No. So I'm going to click the green flag, and my duck says quack, and the cat's thing's gone away. I'm like, oh, how do I make the cat say something? If you look in this corner of the paper here, there's the duck. So you might ask the learners, what would you do next? And then they might say, well, the cat's going to say, meow. Okay, now we want to have under here, we want to say meow by my cat. And you can see what started now is this creative learning spiral. You come up with an idea, you try it, you play with it a little bit. It didn't look right when the duck said hello, and then the cat says meow at the same time. No, I don't want that. Can I wait a little bit? Now put in a little bit of a wait. Quack, meow. So quack, wait, meow. Oh, great. But actually then ducks stop saying quack. So quite quickly we get into this. At MIT, they call this the creative learning spiral. Imagine, make, try, play, share, imagine again. And you keep going and bigger ideas and thinking I could do more stuff. Because now I want him to stop saying something, or maybe I want to, does he have different costumes? Oh, no, he doesn't. And add lots of different backdrops. So I just wanted to connect with this joy of creative learning. For me, I call this thing the loop of joy. So I, for the last 13 years, have been helping to start code clubs with an initiative called Coder Level Up. And those little people in the brackets, there are people with their hands raised, like, woohoo! That's this feeling of joy, right? And that's the thing that for me keeps things alive, is finding the joy as we get through our coding and finding that next level up where you're like, oh, I figured out something new. This is fun. But we need to start at the beginning and then slowly level up through creative learning and create the environments around our young people that works. So we've seen Scratch. So Scratch is a creative learning environment as a tool. The classroom that you create around the learners is similarly a creative learning environment, the way you encourage them to share, the way you let them play with the tooling. And then they're going to go through this creative learning. Oh, and I promised the fact that there's a high ceiling. And some people don't know this. So I'm just going to go back to this tab. And then when you're kind of there, you might say, well, what else can I do with Scratch? Oh, you can play musical instruments. You can do drawing with a pen. You can introduce video sensing with the camera. You can make your projects talk. You can translate into different languages. You can connect it to a microbit and make it do things. If you have Lego bricks, your Scratch can connect all of that. And the face sensing stuff, actually, that just moved out of beta. And so with the face sensing, we should perhaps see my face come in here in a second. So there's my face. And just as a fun thing, because this is very fun, so now we can go under face sensing. And I say, when this sprite touches a nose, so when my duck touches a nose, what should it do? I think it should go to a random position somewhere else. So now I'm going to bring my nose and touch the duck. Boink. So, I mean, if you hadn't seen that before, that's fun. And I kind of just got to do it one more time. That's great. The point there is that is a very high ceiling in terms of computational skill. We're using computer vision, using machine learning, but in a creative learning environment, there's a low floor to get going on it. One more. He's on top of the cat. And now we think about how do we keep raising the ceiling? Because what makes me really sad when I talk to some young people is they say, oh, I tried coding, but it got boring. I'm like, how is coding boring? Because after we've learned this skill, we can learn the next skill. And so what I hope to put in the hands of our learning environments in our country is a collection of level ups. Once we've done this, we could do that. Once we've done that, we can do the next thing. So we've helped to grow this network of coding clubs in South Africa. And coding clubs is a way that you could start as an extramural, a creative learning environment. There's over 1,000 in South Africa now. There's trainers in Cape Town and Durban and Gauteng. If you want to get going, I love it as a pattern. We've got a whole collection of resources here. Just a quick peek. So from Scratch pathways and microbit pathways, Code Club on a stick, so you can do it offline if you don't have internet, the community of practice, how you connect to people, and then more advanced stuff, microbit course from ARM. There's the Make Code Arcade work, the code.org stuff, CS First from Google, Digital Skills for Africa. And that really goes up to, I've learned a lot. And then the next kind of level up in South Africa, we're one of the only countries to have and robotics. So coding and robotics, we then say, okay, well, let's get a little kit. This for $100 with a USB cable that's included, you can plug in and start doing physical computing. And then we continue to think about how do we raise the ceiling? We've got Coolest Projects South Africa as a thing in South Africa that you can share what you've been making. And then start to take part in things. So this is my encouragement to look out there at this first tech challenge, where children build competitive robots, go to the world stage. We've got these Mars rovers and underwater robots that you can run in your classroom, the code, and send them off to the scientists who actually run them on real hardware. And you get back a video of what you were doing in your classroom as you get more and more complicated. But we really need to start at the very beginning and help children to get into that creative learning spiral and not look at it and say, oh, I saw that on YouTube, but it's too complicated. And that brings us to this last point. YouTube's full of AI. The world is full of AI. Everything looks like it's easy, but we actually need to understand at its core how coding works if we really want to be powerful in the future. And so the Raspberry Pi Foundation, I'll put a link to the paper, but I made this infographic to summarize it, has 5 key position statements on why children still need to learn to code in the age of AI. Firstly, AI cannot replace skilled humans. It doesn't have the human judgment and experience to think critically and solve complex problems. It's getting better, but it doesn't have our ability to actually see the world firsthand. Also, if we want to be able to prompt AI very well, we need to have developed the computational thinking mental models, which help us prompt AI as well as function in the world. And we definitely see going forwards that there's going to be new opportunities, not fewer jobs. So as these things become easier to do, we're seeing more demand for software because it's no longer so expensive to make. There's many more demands. And then this idea that having learned to understand code is actually power. We need to program or be programmed. And this idea that it gives you the ability to actually change the world if you know how coding works. That's what we need in our country as we look into how we build the last pillar, which is this shaping this diverse future. If everybody in our country is starting to build this skill of knowing how to code, and the people in this room have the ability to make that change, then we have the ability for everybody to solve the problems that are meaningful to them with technology. And the AI is there as a tool to help us better achieve the world of creating the world, achieve the goal of creating the world that we really want to live in. So I think there's an amazing amount of power and responsibility in our hands to figure out how we can bring the spirit of creative learning into our learners, so that they can really enjoy this coding and robotics and realize that it is for everyone a skill that's super important.
That was so cool, David. Thank you for sharing.
It's always a pleasure. I can go on forever.
So yeah, thank you very much for that. Just a few thoughts there, really. If you are inspired and you want to purchase a microbit, then I think KK, should we publish the United Sphere Funder website, because that would show people where they can purchase their microbits. You're muted, KK.
Thank you very much, Mr. Graham. As part of the initiative to grow communities and to include more communities, we've partnered with the Microbits Foundation. This is really also, we partnered with a technology partner called PictureNet. PictureNet, they are now the distributors of microbits, as well as Kytronic Sports, which works with the microbits. And for every purchase that the schools make, it's helping support a good cause in the communities, where we are able to donate to schools. Currently, I'm in Lesotho. We've adapted the Holy Family School, and that is basically where we are helping support to introduce coding and robotics in African countries as well. So I will pop in the website, where if you need to procure any of the EdTech resources that PictureNet has in supporting of the cause for United Sphere Funder.
Yeah, I put it, actually I have put it in the chat there, the United Sphere Funder website. And I think probably if they go to the blog, then they can find the brochure, which gives them details on how to purchase microbits. And another thing is this. YouTube is fantastic. I mean, I think it's the greatest resource for teaching and learning that's ever been created. And if you're a bit nervous about getting started with Scratch and with MakeCode for the microbit, just put Scratch projects in YouTube or microbit projects in YouTube. There are tens of thousands of them created by kids, teachers, professionals. And they talk you through it with video. Some of them are very entertaining. So have a look at Scratch projects and microbit projects on YouTube. We've got a little bit of time left, and we could take questions now if people want to ask a question. I think possibly there'll be a hand-raising facility. Is that right?
We
Karen,
don't have.
This over to you, because I'm not familiar
we don't
with
have
this,
any. Graham, we don't have any questions in the comments. So perhaps we want to just reflect on some of this evening's discussion.
Yeah, sure. Yeah, I mean, now that you've seen each other's, is there anything anybody wanted to highlight or to contradict, possibly?
No, that's fine. Just to add, keep your eye out for different competitions and promotions and things around getting microbits and things if budget is a concern. We were lucky to receive a limited number of microbit kits, so that's with 10 microbits in it. If you have a registered code club in South Africa and you run the microbit simulator, which you just saw KK showing you earlier, and you pop through images of that, we can get you a free kit to you while stocks last. So if you have a code club, send through your code club link and things, ask me about those details, but it's a great way to get it, and we need to give them away, so we have some to flow out to clubs.
Excellent.
I think what you just said there, David, is so important. If you just keep a lookout, there are often spaces where you can be, one, supporting others, or two, where you can be getting resources at available space at costs and things. So not breaking the bank, but still being able to really start coding and robotics within your space.
Building on that, I think for me, I ran my clubs for 10 years and I never touched robotics. And the reason I didn't is because it felt unfair. Robots felt like something that only rich kids got to do. Until two things happened. One, I came in touch with the microbit, which made it more accessible, but still it's like 300 Rand. That's a lot for a little thing. But the other thing that happens with microbit is sim to real, and sim to real robotics changed my opinion on robotics completely. And what do I mean by that? A sim is a simulator where you can play as if you had the robot. And then the to real part is you could then take it and send that file that you've made over WhatsApp to Keke. She can run it on her microbit, send you a WhatsApp video back, and you can see that it actually works. And I've done that with learners who can't get access, who can't come through. Either I'll WhatsApp them or I'll have a video call with them, and then they'll actually see their code working. And that's super exciting. And I know in under-resourced areas in the Eastern Cape, for example, some lead teachers will say, I have a microbit. If you'd like to do one of your things in the classroom and send it to me, then I will run it on it. And then the next time that person comes visiting, they can show you the code. So sim to real lets that come to life.
But I will make a prediction, because I've seen it in 40 or 50 countries throughout the world. The microbit will become the resource for the South African Ministry of Education, and they will be putting it in all their schools. Hopefully, obviously, the Ministry of Education will find the budget to do this. Where there are in more disadvantaged communities, then they'll be raising money to do it. But you have to have the physical device to teach physical computing, and it will be a responsibility of the South African government to do what education ministries have done throughout the world, that's put the device in the hands of their learners.
So I want to add to what David said, but I want to look at it the other way around. So I trained as a foundation phase teacher many, many years ago. And I was then offered a course for high school teachers, which was then called technology. And I'd never done coding, but I was exposed to coding lathes and milling machines and robotic cells and gardens with growing, all with coding and all sorts of crazy things, which I never actually saw in a school. The technology was just so way advanced. You didn't actually get it in a school. But I took my foundation phase head and I thought, we can teach these robotics. So the skills like levers and wheels and axles. And then in those days, you didn't really have microbits and things, but adding a motor, and like Graham taught with design and technology, where you started without doing the coding, but you got the children to understand how the mechanical systems worked, how the electrical systems worked. And so you got your children to do amazing things, often with very little resources. In fact, to this day, my best material for building structures is thatching grass and less than 0.5 meter of masking tape, because it just teaches them so many principles and skills about so many different things. But so for me, it's saying, how do we start with what we've got? and how do we teach the concepts of what those are? And when we get resources, we can add to it. So now you've got microbits, and even on these robots made out of cardboard and wheels and all sorts of things, you can now plug in a microbit and off you go. So you don't always have to be buying the expensive robot things. And I suppose that's what we should also be saying this evening is, how do we think creatively, not just in terms of our children, but how do we as teachers think creatively in how we can actually be teaching the children these concepts? How do we extend ourselves as teachers and just go and play with the things ourselves? Because when we start having the fun, the kids do.
And it's about finding that play. Sorry, Keke, please go ahead.
No, after you did.
Okay. So I want to say, Graham, thank you for somewhat contradicting me, and I hold that hope too, that we'll see a larger rollout of microbits as well as computers. Before microbits, we need some form of devices to do the coding on, and that's going to take time, and figuring out how we do that is a continuous process. We're very lucky here in the Western Cape that we've got a very good rollout of computer rooms. Now it's the problem of seeing them used, and then the next part is doing a microbit rollout. If you don't mind, I'm going to share my screen one more time because I want to show you something that's a lot less accessible than a microbit. Let me see if I can do this. So what Sim2Real allowed to come true for me is that learners can get access to a robot like this. Now, a problem with a robot like this is most teachers would not be very comfortable making one. As an electrical engineer, it was a bit daunting for me to think about it for the first time. And then it breaks in mysterious ways. But with Sim2Real, we've got 2 Mars yards running with these rovers in them that learners can then write code in the classroom and get back a video watching it going around. And then if they can get through to the science center, they can actually come and have a look at.
Okay, we've only got a couple of minutes left. I wanted to give Keke a chance to
100%. I just wanted to show you this idea that you can actually now connect to the super advanced robot.
Yeah, I think we'll time Keke out if we. Sorry, Keke, did you
Thank you.
I wanted to show you the whole video. That was a teaser, just to be like.
Alrighty. No problem. Gentlemen and Karen, thank you so much for your time. So basically, on my closing remarks, there's that educator who was born before technology. I'm talking on behalf of them. There's that child in the rural area that doesn't really know what we're talking about. And basically, we're saying, let's have an inclusive approach. It doesn't matter what the resources you have. What is important as an educator, you must understand the pedagogy, understand the key concepts, because then it allows you to be creative. You see, we have designed our own local robots using the microbits. United Safuna has now its own robot. We do not need to go and buy robots. So meaning we can cover many communities. Just on the closing side, I want to say shout out to Lesotho. I am here. Today I was at St. Stephen's. Shout out to Machabeng. We hosted the World Robotics Olympiads in-house competition. Sophia has an upcoming competition now on the 23rd of April. You can see Lesotho is buzzing now with coding and robotics. And I'm missing my fellow colleagues and everybody there in South Africa. I can't wait to see you guys because we will be having boom boards coming up as a competition that will be hosted together with the Microbits Foundation. Thank you.
Okay, well, I think that's spot on time. So I think we're going to leave it there. Have a look in the chat. There's some useful links. You can pick those up. Karen, is there any way of getting any of these links to people once we've finished?
So these will stay live on the different platforms. So on YouTube and on Facebook. And I'll go and pop them into LinkedIn. LinkedIn doesn't allow us anymore to do that, but I'll go and paste them into LinkedIn.
Okay. So thank you very much to David, KK, and Karen. I hope that was useful and informative. And please do follow the links. So it's a goodbye from me. Okay. Goodbye.